how many cards? 52, of course. And let's consider the case if we are taking one card out of the deck, and so let's denote by a the event that this card is an ace. Ace. So, and also let's consider the B event. And what does the B event says? That the card is a red suit. So now how we could put this information on the table. So there is two dimensions. One that says that there could be ace or not ace, and the other says that the card could be red or black. So and why does these two stand here? Because there are just two a's which are red, right? And also two black aces. And all other cards are here, of course. How many blacks are there?
6.
Same as reds. And how many a's are there? 4. Of course, 4, and the rest is 48. Now, let's calculate the probability that the card is red and or ice. Yes, this is or. This is union and this is intersection. Intersection stands for the and the union stands for or. And we know that if here is or, then we need to multiply the probabilities and subtract the joint probability. So what is the probability of being red? So here we see that there is 26. So we have 4 A's and we need to divide it by 52. And here is this number. And we need to subtract the joint probability that the card is red and ace. And how many cards are there which are red and they are ace? So we need to look at the intersection of these two directions. And here is 2. And of course, we need to divide this 2 by 52. And we put it here. And whenever we calculate the entire probability, we get 38 over 52. And do you remember why we're subtracting these two cards? Because when we were calculating the probability of being red, we counted these two once already. And when we were calculating the probability of being ace, we counted these two the second time. And of course, we need to subtract it once in order to consider it just one time. Okay, and we are at about till lemons and orange. How many lemons are there? And orange are 5, so we need to sum them up and divide by 35. But why we are not subtracting anything from them? We know that there was a formula that will say that we need to subtract something. Are these events overlapping? Getting a lemon and getting an orange. So if you take one and you get a lemon, then you will not get the orange. So these events, getting a lemon and getting an orange, are not overlapping. If it happens one, then it doesn't happen the other. And because of that, we are not subtracting anything. Okay, now we are going to study so-called conditional probabilities. And there are these ultimate formulas. But first of all, we need to learn how to read this formula. So the probability of happening A, given that B have already happened, is equal to the probability of joint happening of A and B divided by the probability of happening of B. And vice versa, when we change the names, then this part is not changed because the intersection of A with B is the same as the intersection of B with A. So we just need to change this number here. Here stands B, whatever is given, and here stands A, whatever is given. So now, in order to calculate these probabilities, we need to have some information, and we need to consider this example. And what does this example says? Of the cars on a used car lot, 70% have air conditioner, and we denote air conditioner by AC. And 30% have CD players, and just 20% of them have both of them, CD players and the air conditioners. So now this information is presented here on the table, and you need to know how to present this kind of information on the table. So, first of all, here are cars with CDs and with no CDs, and also with air conditioners and without air conditioners. And what we are given, 70% have air conditioners. So, here are air conditioners, and their sum should be 70%. Then, 40% have CD players. Here are CD players, and in total, they should be 40%. And finally, 10% of them have both. Both means that we need to find an intersection place and put this 0.2 here. And if you are given, for example, these three numbers, can you calculate the others also?
Yes.
Yes, of course. If we are given 0.7 and 0.2, then here should stand just 0.5 because they need to sum up to 0.7. And the same is with 0.2. Here we need these two numbers to sum up to 0.4. And of course, if we know this number, then we know that the number that is here should in sum be equal to 1. So, and now how to calculate that the car has a CD player, probability that the car has a CD player given that it has an air conditioner.
Sure.
So as far as we are given the information that the car already has an air conditioner, we are considering just this part. And we don't look the other information. And so then we need to find the probability that the car has CD players and air conditioners. And this is the intersection of these two directions, and this is 0.2. And we need to divide it by the probability that the car have just an air conditioners, and this is 0.7. So we need to divide this number by this number, and we get the result.